Now to our question 4 of this. Here we have binomial expansion tested in combination with a question of combination. So we're going to take the binomial first. That's 4a. It says obtain the first 4 terms of the expansion of 2 plus y over 2 raised to power 8. Y over 2, all of this raised to power 8. Here, for question 4, we want to write the first 4 terms of this given expansion. So, what we do is, in order not to give ourselves a headache, it's better we write the binomial expansion, the generalized form. This one is n combination 0 a raised to power n. At this point, b is raised to power 0 plus n combination 1 a raised to power n minus 1 b plus n combination 2 a raised to power n minus 2 b squared, and so on like that to n combination n a raised to power n minus n b raised to power n. And this one will give, for the first few terms of n, we have n combination 0. That one using, this will be n factorial over 0 factorial n minus 0 factorial. And so this will give us n factorial over n minus 0 factorial, which is n factorial. 0 factorial is 1. So this will be 1. So the coefficient of the first one here is 1. And so we have, I think I should use it here. So we have this equals to a raised to power n. And for n combination 1, we have n factorial over n. This one is not part of our, I'm just using this one to explain, so you will see that the work is very little anyway. So we have n factorial over n minus 1 factorial 1 factorial, and this will give us n multiplied by n minus 1 factorial over n minus 1 factorial 1 factorial, and this one gives n over 1. Since 1 factorial is 1, I think factorial notation has the property that 0 factorial equals to 1 factorial equals to 1. We should take note of this. It's very important. Now, the next term here is for n combination 1, we have n. So we have n multiplied by n minus 1 b plus, we want to get the next term now, which is n combination 2. N combination 2 now will be n combination 2, this is n factorial over n minus 2 factorial 2 factorial. This will be n into n minus 1, n minus 2 factorial over n minus 2 factorial 2 factorial. This will go, and this will give us n into n minus 1 over 2 factorial. So this, the next term here will be, this is obstructing what I want to do. I think I should write it and put it as n combination n a raised to power n minus n b raised to power n. So the next term here is n into n minus 1 over 2 factorial multiplied by a raised to power n minus 2b squared. Okay, and so on. So that implies that the next will be n combination 3 now. That will now be n into n minus 1, n minus 2 over 3 factorial a raised to power n minus 3 b raised to power 3 plus continuously like that until we get to n combination n. N combination n, I have skipped n combination r because of our time. So n combination n now will be n factorial over n minus n factorial n factorial. N minus n is 0, 0 factorial is 1. So we have n factorial over n factorial, that will give us 1. So last time we have we're going to get this will be 1 a raised to power n minus n. That will be a raised to power 0. So that will be 1 also. So we have b raised to power n as the last term here. So we want to use this one now. We just come and wherever we see a now, we substitute 2. Wherever we see b, we substitute y over 2. Wherever we see n, we substitute 8. Therefore, all of this one now is equals to, using this expansion down here, we have that will give us for a 2 raised to power 8 plus n, which is 8, multiplied by our a, which is 2. 8 minus 1, that one is 7 raised to power 7, multiplied by what is our b? Our b is y over 2 plus, this is the first term, second term. The third term now will be n into n minus 1, that is 8 times 7. 8 times 7 should be, do I have a calculator here so that the work will be faster? So this will be 8 times 7, I have 58, 56 over 2 factorial is 2 times 1. So a raised to power n minus 1, my a here is 2, so I have 2. This one will be multiplied by 2 raised to power 8 minus 2 now, which is 6, 2 raised to power 6, multiplied by, what is my b? Y over 2. Y over 2 raised to power 2 plus the next one, 2, 3. The fourth term now will be this. That will be 8 by 7 by 6. So this one multiplied by 6. I have 336. That will be 336 divided by 3 factorial 6, multiplied by our a, here, which is 2 raised to power 8 minus 3, that will be 2 raised to power 5. B, that will be y over 2 raised to power 3, and so on like that. So I think we are done with this guy now. And now this will give us, okay, dots. And now this will give us, I think I can still manage this place, 2, 5, 6. This will go to reduce this guy to 4. 4 by 1, 2, 8. 4 by 1, 2, 8 here is 5, 1, 2 plus 5, 1, 2 y. Here, this will go 4 here, that will be 4 in 6, 1 in 24, that's 16 by 28. So we have 448 y square plus 448 y square plus the next one now will be 56 by, okay, 8 here, 1, 8 and 32, I think that should be 4 by 56. We have 224 y cube. 224 y cube, and so on like that. So this is what we have for the expansion. The first part of the question is that we should obtain the first 4 terms of the expansion of 2 plus y over 2 raised to power 8. We have answered the first part. The second part is that in ascending power of y, okay, hence find the value of 2.005. The next part of the question is that we should find the value of 2.005 raised to power 8. Therefore, 2.005 raised to power 8. We will compare that one with 2 plus y over 2 raised to power 8. Okay, we want to put this in this form now. So this will be 2 plus 0.005. That one will give us 2.08. All of this one is power 8. So that this one now will give us, so this implies that our first term here is now 2, which is this, and it implies that this implies that 0.005 is equal to y over 2. So to get the value of y now, we multiply this one by this. So 0.005 times 2, which is 0.01, I think. Yeah, is now equals to y. Our y will be 0.01. So we substitute that one into this, and it will give us the values of the 2.005 raised to power 8 now will be equals to 256 plus 512 into 0.01 plus 448 into 0.01 square plus 224 into 0.01 raised to power 3 plus dot. That's what we have here, and this will give us all of this. When we put it in our calculator, we have 256 plus 5.12 plus 0.0448, and next is 0.000224, 0.00224. And so on. So if we put all of this together, we have, therefore, this will give us 2.005 raised to power 8 will give us 261.16, which is the required solution for question 4A. Now, question 4B here. We should say in a class containing 10 boys and 6 girls, find the number of ways to select 4 boys and 3 girls. I think I should write the question now. A class containing 10 boys and 6 girls. Find the number of ways. This one is very straightforward. Find the number of ways to select 4 boys and 3 girls. To select 4 boys and 3 girls as representative of the class. Of the class. So here, in all of this information, all we needed is the number of boys and the number of girls, the total number of boys and total number of girls. And we want to select 4 boys out of 10 boys and 3 girls out of 6 total. That implies that we have 10 combination 4 multiplied by 6 combination 3. That's all we needed here. Since this selection is of combination, if it is of computation, we can have more. But now, for combination, we have this, and this will be 10 factorial over 10 minus 4 factorial multiplied by 4 factorial multiplied by 6 factorial over 6 minus 3 factorial multiplied by 3 factorial. So the rest is just arithmetic. For 10 factorial, we have 10 times 9 times 8 times 7 times 6 factorial. I'll stop here because we have a 6 factorial in the denominator, multiplied by 4 times 3 times 2 times 1. All of this multiplied by 6 times 5 times 4 times 3 factorial over 3 factorial times 3 times 2 times 1. So in all of this we take this. 4, we take 8, we have 2. 2, we take this 2. 3 here, we take this 9, we have 3. So that implies we now have 10 times 3 times 7. 10 times 3 times 7. We have 210. So I think I can remove this one now. We are done with this. So in that we have 210 multiplied by, for this one now we have 3 factorial, we take 3 factorial, 2, we reduce this one to 2, 3, we also reduce this one to 2, so we now have 2 times 5, 10 times 2, that will be 20, 210 times 20, this one times 20, that is 4,200 ways that we can select 4 boys and 3 girls from a class of 10 boys and 6 girls to represent the class. In the case of question 5, it cut across. Some departments, they have matrices as part of their coursework, as part of their course content. Some departments have trigonometry in replace of, some have complex numbers. So what I'll do here is I'll pick one from those areas and we solve. So for question 5, in this particular department, they have matrices. It says solve for x if, solve question 5 solve for x if x23 1x0 6 1 minus 2 6 1 minus 2. If the determinant of this is equals to 7, this one is straightforward. Some question will coin it, they will just say, they'll give you this matrix and say they want to test if you know the definition of singular matrix. It will just say, okay, for which this one is singular, so you have to equate it to 0 and find the values of x. But here it is equated to 7, so straightforward. Let's take this. Now, the determinant of this will be x multiplied by, we delete the remaining element on the same row with this and the remaining element on the same column with this x, the first element here, so that we are left with x0, 1 minus 2 multiplied by, we do the same here, we have 1 0 6 minus 2 1 0 6 minus 2 plus 3 multiplied by 1x 6 1 1x 6 1, all of this equals to 7. And so we have x, the determinant of this will be this, minus 2x times this will be 0 plus 0, minus 2 into 1 by this, we have minus 2, 6 by this, 0 is also 0, so that one will come, plus 3 into 1 by 1, 6 by x, that will be minus 6x, all of this equals to 7. So we now have x by this, we have minus 2x squared. Minus 2x squared. This minus 2 by minus 2 we have plus 4. And in this we have 3 by 1 we have 3. This will be plus 3 minus 3 by 6, that's 18, minus 18x equals to 7. So we can now reduce this. This is minus 2x squared plus 7. If I take this one outside, or I bring 7 inside, it will delete. Okay, plus, okay, minus 18x plus 7 minus 7 equals to 0. So we now have minus 2x squared minus 18x equals to 0. This is quadratic. Here, we can factor x so that we now have x is common here. I'm left with minus 2x, and here we have minus 18. So that when we open this, we have this equals to 0, and this implies that x is equals to 0, or minus 2x minus 18 is equals to 0, and therefore that will give us minus 2x now equals to 18, and x is equals to minus 9. That will be the value of our x in that case. I think that one is straightforward enough. Another question here says we should define the following terms. That's 5b1. Define the following terms. 1. Null matrix. 2. Diagonal matrix. And 3. Adjoint matrix. For null matrix, Roman figure 1, null matrix. This affects candidates who will not attend classes, but they just want to, they believe in the word that says idea is needed. But in mathematics, you have to know your idea may not be accepted if not proven. So for null matrix, in null set, we define it as an empty set, a set without elements. But a matrix, null matrix, is a matrix with 0 elements. So they are not the same. Null matrix, in a nutshell, is a matrix that has, or which has, all its elements equal to 0. Okay, that is, we have A now equals to 0, 0, 0, 0, or B, a column matrix 0, 0. This is an example of a null matrix. Number 2, that we should define diagonal matrix. A diagonal matrix is a matrix that has 0 element except in the leading diagonal. That is diagonal matrix. I think it's better I write this. Is a matrix that has 0 elements except in the leading diagonal. That is, Aij is equals to 0 for I not equal to j, and Aij is not equals to 0 for I equal to j. For example, if we have A now equals to A 0, 0, 0, B 0, 0, 0, C. Non-zero in the diagonal. All other elements there are zeros. 3. Adjoint matrix. The definition for adjoint, that one is and on the cofactor matrix. The definition of adjoint matrix is adjoint matrix. The adjoint of a matrix is the transpose. This is the transpose of the cofactor matrix. The transpose of the cofactor matrix. So if we are given a matrix, okay, I think the next part of this question, 5b2, is that compute the adjoint of A. Okay, if A is 1 minus 1 3 minus 1 1 2 and 3 2 minus 1, that's a complete question there. That completes question 5. We want to compute the adjoint of the matrix. This one is a long one. 1 minus 1 1 minus 1 3, long but short, but easy. Minus 1 1 2, and then 3 2 minus 1 3 2 minus 1. We want to compute the adjoint of this. So what we want to do here is, in order to compute adjoint, you have to first compute the cofactor. How do we compute the cofactor? We compare this with the general form of this. This one is telling us the position of each element of a matrix. So for each of these, the cofactor of a matrix is defined as the determinant of the matrix obtained by deleting the ith row and the jth column multiplied by minus 1 raised to power I plus j. So what we want to do here is we pick each of these one by one and compute a matrix element for all of them that will now later make the cofactor matrix. Now, in this case, let's take it one by one. For A11, we want to compute the matrix element for this. This will be minus 1 raised to power 1 plus 1 multiplied by. For A11, when we compare here, it is this. So we delete this and this, we are left with this matrix. This 2 by 2 matrix. 1 2 2 minus 1. We compute the determinant, we multiply by this. That's the cofactor element for this. And we have so this one is just to determine the sign. Minus 1 raised to power 2. That will be plus 1. If you like, you can write 1 there. So we have minus 1 minus 2 times 2, we have 4. This will be minus 4 times 1, minus 4. Sorry, minus 5. And for A12, we have minus 1 raised to power 1 plus 2 multiplied by, this is A12, we delete this and this, we're left with minus 1, 2, 3, minus 1. Minus 1, 2, 3, minus 1. This will give us minus 1 raised to power 3 will be minus 1 multiplied by minus 1 by minus 1, 1 minus 6. This is minus 5 by minus 1. This will give us 5. The next one will be for A13. We have minus 1 raised to power 1 plus 3 multiplied by, this is A13. So we delete this and this. We are left with the 2 by 2 matrix. Minus 1 1 3 2. We compute the determinant of this and we have minus 2 minus 3. This will be minus 5. And for A21, we have minus 1 raised to power 2 plus 1 multiplied by, this is A21 now. We delete this and this. We are left with the 2 by 2 matrix. Minus 1 3 2 minus 1. Minus 1 3 2 minus 1. And this will give us minus 1 multiplied by 1 minus 6. This is also minus 5. By this we have 5. For A22, For A22 we have minus 1 raised to power 2 plus 2. So as the exponent, the power alternates. For even we have addition, we have positive sign, and for odd we have negative sign. Now in this case, for A22, this is A22 compared with this. So we delete this and this. We are left with the 2 by 2 matrix 1, 3, 3, minus 1. 1, 3, 3, minus 1. And this will give us 1 by minus 1, we have minus 1, minus 9. This will be minus 10. So the next we have for I think I should use up here as well, because I still need all of this. For A, I've done A22 now. For A23, we have minus 1 raised to power 2 plus 3 multiplied by, for A23, this is A23, we delete this and this, we are left with 1 minus 1, 1 minus 1, 3, 2. If we delete this and this, that's it. So we have a minus 1 multiplied by 2 plus 3. This will be minus 3. So we have this, and this will give us minus, this is 5, by this we have minus 5. And now, for A31, we have minus 1 raised to power 3 plus 1 multiplied by, here is A31, we delete this and this, we are left with minus 1, 3, minus 1, 3, 1, 2. That will give us minus 2, minus 3. This will be minus 5. Minus 5. And now we are left with, I think I should remove this, because I still need all these values. For A32, we have minus 1 raised to power 3 plus 2 multiplied by, if this is A32, we delete this, we delete the ones on the column, we are left with the 2 by 2 matrix 1, 3, minus 1, 2. 1, 3, minus 1, 2. And this one will give us minus 1 into 2 plus 3. 5. By this we have minus 5. And for A33, which is the final one now, we have minus 1 raised to power 3 plus 3 multiplied by A33. We delete the remaining element on the same column. Those on the same element, those on the same row, we have 1 minus 1 minus 1 1 1 minus 1 minus 1 1, and this will give us 1 by 1 1 minus 1 by minus 1, we have 1, that will be minus 1, this will be 0. Therefore, our cofactor matrix for this given matrix now will be, I want to remove this one also, so that we can now write our cofactor matrix. Therefore, the cofactor matrix A raised to power C, or C, is equals to, my A11 now is minus 5, A12 5, A13, that's minus 5 also, A21 5, A22 minus 1 minus 9 minus 10, okay, minus 10. Then A23, that's this, minus 5, A31 minus 5, A32 minus 5, A33 0. This will be the cofactor matrix. So the question says we should compute the adjoint. So what we want to do, we have defined our adjoint as the transpose of the cofactor matrix. Therefore, our adjoint matrix, now, adjoint is always, in most cases, denoted by adjoint of matrix A, the given matrix A, will now be the transpose of this cofactor matrix. That is, we change the row for the column. The second row now will be our second column. And the last row will be our -5, -5, 0. Question 6. The question says, if tan theta is equals to 3/4 and theta is within 0 and 90 degrees, okay, that is an acute angle. And now the question says, evaluate sin theta, cos theta, and sec theta. Evaluate sin theta, cos theta, and sec theta. Very straightforward. From here, if tan theta is equals to 3/4, therefore, this is a tangential function. If we have theta here, that implies that we have two opposites over adjacent. So we need this third side to continue. Now, by Pythagoras, we know that x squared, which is the longest side, the square of the hypotenuse is equal to the sum of the square of opposite and the adjacent. This will be 3 squared plus 4 squared. And this one is 9 plus 16, 24, sorry, 25. So if x square is 25, x will be root 25, which will be 5. Now this side is 5. Therefore, now that we have all these sides, therefore sin theta is equals to, we only need the hypotenuse to compute sin theta and cos theta. So sin theta now will be opposite over hypotenuse, 3/5, straightforward. And cos theta is equals to adjacent over hypotenuse. And sec theta now, which is the reciprocal of cos, that will be, therefore, sec theta, which is 1/cos theta, will be equals to 1/4/5. That will be 5/4. I think sec cosecant is sine. Okay. So for the second part of that question, is that if y, I think I can remove this when I'm done with this. If y is equals to a cos theta, if y is a cos theta, show that a square minus y square, show that or prove that a square minus y square is equals to a square sine square theta. A square sine square theta. This one is not so difficult. From here, since we have a y square here, we can follow that approach. Y, given that y is this, therefore y square will be a square cos square theta. If we square both sides of this, we have this. And therefore, a square minus y square now will be a square minus a square cos square theta. In this case, if I factor a square, we are left with 1 minus cos square theta. And we know that, you can say recall that, or we know that, any which way, recall that From the first trigonometric identity that we have, sine squared theta plus cos squared theta equals to 1. From here, sine squared theta will give us 1 minus cos squared theta. And therefore, we can substitute this in place of this. Let's call this star. Therefore, equation star becomes a square minus y square equals to a square multiplied by 1 minus cos square theta, which is now equals to sine square theta, which is the required solution. That's what the question asks us to prove, this, which is now this. I can remove this guy so that we can quickly have the second rule here. This one is we should simplify the square root of 1 minus cos theta over 1 plus cos theta. Okay, so here what do we do? This one has radicals, so we can separate this using one of our the second rule in sorts. 1 plus cos theta, and we rationalize this so that we now have 1 minus cos theta over root 1 minus cos theta. This by this we have 1 minus cos theta over this by this. We now have roots 1 by 1, 1 by minus cos theta, we have minus cos theta. Cos theta by 1, we have plus cos theta. And cos theta by cos theta, we now have minus cos squared theta. So this gives us 1 minus cos theta over roots minus cos theta plus cos theta, that will be 0. So we are left with 1 minus cos squared theta. Let's take it again from the first identity where we have sine squared theta plus cos squared theta equals to 1. Sine squared theta is 1 minus cos squared theta, and this implies that sine theta, if we take the square root of both sides, sine theta will give us root 1 minus cos squared theta. Okay, and now we can substitute that one for this, and this one here, star, becomes 1 minus cos theta over sine theta, and this one here is equals to 1 all over sine theta minus cos theta over sine theta. And therefore this gives us cosec theta minus cot theta. This is the required solution. This brings us to the end of the past treatment of past questions of year 1 student. By Gospel Our Life, we will have the remaining classes, and our candidate will definitely find them useful in preparation towards their exam. Thank you so much for your time. And if you have any concern, it's not too late. You can pass them through the comment section. We will attend to you. Thank you for your time.